Okay, this practice example is for the direct variation, constant of proportionality, slope, and unit rate. So consider the table. Note that the ratio of the two quantities is constant, 20 over 2, 40 over 4, 60 over 6, indicating proportional. Okay, I want to stop for just a second right there. Two things are happening. If you remember, if I have a pattern here, see how this is increasing by 2, increasing by 2, increasing by 20, increasing by 20, that says it's linear relationship. This does not show if it's proportional. Be very, very careful and clear. Just because there's a pattern with my x's and y's does not mean it's proportional. That means it makes a line. Doesn't promise you that the line goes through the origin. The only way to know that the line goes through the origin other than looking at it is if the ratios are equal. Okay, yeah, you could go through and see if I could extend this out and see if I have a 0, 0 as an ordered pair. But creating ratios is the best, most efficient way to determine if it's proportional. Okay, this relationship is called a direct variation. So if it's proportional, it's called direct variation. Okay. So the next little part says, consider the graph of a line containing these points. Determine the slope. So my change in y is 20, my change in x is 2. You could have also done this by using a rise and a run. My rise is 20, my run is 2. 20 over 2 simplifies to 10 over 1. Okay. What does this mean? $10 earned per hour of babysitting. So this is where we start asking you questions about what's happening in this graph. So the slope being 20 over 2, when it says what does this mean, it's basically asking what the unit rate is. Okay, so it's basically what they're doing. What does this mean? What does that slope of 10 mean? Okay, it's asking what the unit rate is. So it says, recall, this is also called the unit rate. Therefore, note that the constant of proportionality, the slope, and the unit rate all have the same value. Now you'll notice number 3 on your practice test has this exact question. So this may help you answer that. Okay. So example problems. Determine the unit rates. Bamboo that grows 5 inches, 5 inches in 2.5 hours. I want to know how much does it grow in 1 hour. Okay, now this is a little trickier because we have decimals. The way we would handle this with decimals would be, I would say, well, for me to get 2.5 to become 1, I need to divide by 2.5. So that means I'm going to take 5 inches and I'm going to divide by 2.5. And I get 2. So my unit rate for bamboo grows at 2 inches per hour. That's my unit rate. Okay, for my cyclist here, I go 3 hours, 24 miles, 6 hours, 48 miles. You have a couple options. You could do the slope formula. I could say y2 minus y1 over x2 minus x1. And I could say, okay, when I subtract that, I get 24 over 3, which simplifies to 8 over 1. So my unit rate for the cyclist goes 8 miles per hour. Okay. The other option you could have done for this problem would have been, I could have said, okay, well, if I go 24 miles in 3 hours, how much in 1 hour? And I could do the same thing I did on number 1. I say, well, 3 divided by 3 is 1 hour, so 24 divided by 3 is 8 miles. 8 miles in 1 hour. That's my unit rate for the cyclist. And my last one is a graph. Now from the graph, I'm going to find the slope, or the rise over run. So I'll put my 2 points that cross the grid marks. I'm going to rise 2, I'm going to run 1. So my slope is 2 over 1, which means, now it doesn't even tell me what is happening, what's happening on my graph here. So slope equaling 2 over 1 would be your unit rate. And that's it.